Welcome to Shendra's engineering tutorials. Yet another important from Z transforms from the courses, which is common to both the courses digital signal processing and signals and systems. That topic which cannot be neglected, which cannot be put aside. Very much linked with some other deductions, very important deductions, I should say. So important one. Stay with me if what the discussion to see what the discussion is. Here you might have come across what is a step function u of n, u of t in case of continuous, and we are talking about Z transform, guys. It's a discrete time, right? So what will be u of n? U of n is a step function which is equal to 1 for n greater than or equal to 0. What will be the representation of this one? It's a graph with n on this side, n equal to 0, it's a 1, n equal to 1, it's a 1, n equal to 2, the magnitude is 1, n equal to 3, the magnitude is 1, and dot 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 extends up to infinity. It exists only for n greater than or equal to 0, not beyond this one. Beyond this one, this signal is invalid, right? That doesn't exist. So what will be the Z transform of this one? Very important, guys. Whatever deduction we go for, lot many deductions will end with this one. So that's what I mean. So what is a Z transform? A given function. What is a Z transform? X of n will be given. The discrete signal x of n will be given, multiplied with z raised to minus n, and summation will be obtained from n equal to minus infinity to plus infinity, according to the definition, bilateral Z transform they call, and that will give us x of z, whatever the transformation, n domain, the discrete time to z domain, right? So this is the case. And we have another one, like the summation will be from, in some cases, especially when a signal is multiplied with u of n, that signal will be existing only from n equal to 0 to infinity, not negative infinity. In that case, we will be having a unilateral Z transform, which the summation will be from n equal to 0 to positive infinity. The given signal x of n will be multiplied with z raised to minus n, and even that will be Rx of z. The resultant will be Rx of z, right? So if this is the case, this is the procedure to evaluate the Z transform of any signal. What will be the Z transform of u of n? What will be the actual? We have come to the actual point. Stay with me. The Z transform of u of n is defined to be 1 into z raised to minus n, and where the summation starts from, because this signal u of n exists only for n equal to 0 to infinity, the summation n will be equal to 0 to positive infinity, right? Hope it's clear. Now how will be the extension, like how the summation will be? N equal to 0, it will be 1 into z raised to 0, that will be 1, plus n into, what is the next one? N into n is equal to 1, that will be 1 into z raised to minus 1, plus what next? N equal to 2, that will give us z raised to minus 2, plus what is next in the place of n? After 2, it's this negative is carrying, okay? So don't, where did this negative come from? That is from the definition itself. And plus n equal to 3, that will be z raised to minus 3, plus dot dot dot, that extends to infinity. Okay, so what is the how to bring it to a standard form? We have a formula, sum of infinite geometric series. We have a formula. What is that? Summation, this could be reduced to the summation, it's like the first term a by 1 minus r. So what is this a? It's a first term of the series, 1 minus, what is this r? Focus on that r. It's the ratio between each and every term, common ratio. What is the ratio? This by this gives the ratio, this by this gives the ratio, this by this gives the ratio of the series. In that case, what is this? If this is this by this, it's here, over here, z raised to minus 2 by z raised to minus 1. 1 of z raised to minus 1 gets cancelled, and this will be like 1 of it will be z raised to minus 1. So that is the ratio, common ratio. Now this will be the common ratio r. What if here ratio between these two, it's a z raised to minus 1 by 1 between these two, even that is z raised to minus 1, right? So in this case r will be this one, the common ratio between each term will be. So in that case our deduction will be, a is the first term of the series, it's a 1, and from the formula it's 1 minus, what the ratio, just now we have seen that to be z raised to minus 1, z raised to minus 1 inverse z inverse, right? In some authors stop over here, some authors go ahead of still simplifying this one, 1 as it is from the numerator, and even this is 1. What is z inverse? Minus 1 by z, isn't it? So obtaining the LCM of the denominator, 1 as it is, and it's a LCM will be z, isn't it? And cross multiplying here, guys, it will be cross multiplying, it will be z minus 1, and this flips up, isn't it? So the final reduction will be z by z minus 1. Okay, so I need to say something in this context. The z transform of u of n will be equal to z by z minus 1. Okay, so in this context the inverse z transform, here there is change in the color, inverse z transform of this one, and inverse z transform, z and inverse z, this gets cancelled. Okay, z and inverse z, this exists no more, and here from this expression what we say is inverse z transform of z by z minus 1 will give us u of n. Very, I can say that it's a deadly important deduction, right? Almost 90% of numericals related to z transform will be concluded with this one, inverse z transform of z by z minus a equal to u of n, right? Wherever we come across this one, and if that is the if we have to obtain the inverse of z inverse of that one, that will we can straight away right away this one, the inverse of this one is this one. Make a note, please. What is the z transform of let's see, what is the z transform of function a of n, a raised to n, u of n? What will be the z transform of this one? Let's see. So definition, according to the definition, what is the z transform of any function? A of n multiplied with z raised to minus n, and because of this one, u of n, the step function, discrete step function existing from the summation will be equal to n equal to 0 to infinite, isn't it? According to the definition. Now how to spread the summation? It starts from n equal to 0. When n equal to 0, a raised to 0, z raised to 0, that will be 1. So it will be, the first term will be 1. And what else? The next is n raised to 1, right? So that will be a z raised to minus 1. What is the second one? It's a raised to 1, so that's okay. And the second one is a square z raised to minus 2 plus dot dot dot, it extends up to infinity, right? The same way, what will be the common ratio? This by this will give us that this by this term, the second term by the first term gives us, says that the common ratio r equal to, what is that? A z raised to minus 1. Do this one, one gets cancelled and we'll be left with this is the common ratio for this ratio, right? And here so in that case, in that way we have the reduction of summation, infinite summation, geometric series something. We have, what is that? A, the first term by this, not this one, okay, there's something else, the first term by 1 minus common ratio r, and this is our r in this case in the series. So that will be, what is that? For a is the first term. What is the first term over here? It's a 1 upon 1 minus, what is that common ratio? A z inverse. Some authors stick to this one, some authors go ahead, and it will be advantageous, it will be more clear if you go ahead. It's like z inverse, it's a 1 by 1 minus a z inverse, in the sense 1 by z, right? So simplifying this one, that will give us the LCM, it's a z by cross multiplying this z into this minus a upon 1, that will, this flips up, I'm very sorry, that's z into 1, that's z, minus 1 into a, that's a, I'm very sorry, and this one, it's a denominator of the denominator flips up, right, and the final reduction will be z by z minus a, right. So this one, and here once again what is that, the z transform of a raised to n u of n is equal to what did we find out that to be, z by z minus a is the reduction, right. So inverse on either side, z raised to minus 1, z raised to minus 1, inverse and z and its inverse, this gets cancelled, and inverse z transform of z by z minus a will give us what, a raised to n u of n, guys. So here this one, whatever term z by z minus, this should be in minus, okay, this should be minus a, that can be written as a of n u of n when we have to evaluate the inverse, when there is a need of evaluating the inverse z transform. Definitely we have to, majority of the cases, majority of the numericals will be, majority of the numericals will be concluded with this reduction, which gives us the inverse z transform to be this one. Yet another important game changer, I should say, yeah, it's a game changer. A lot of numericals can be simplified. If you at a snap you can say that the final result is that one, right. Make a note please, even this is one, a star 5-star rated z transform of any function x of n. What it is, x of n is multiplied with z raised to minus n, and summation is obtained from minus infinity to plus infinity, or 0 to infinity, or minus infinity to 0, according to the given function, etc. And for my convenience, let me say that it's n equal to minus infinity to plus infinity, right. And what if some mathematical operation on either side of the equation, mathematical operation, what will be the resultant if you go for a d by dz on either side of the whole function? Where do I write down d by dz of on either side, right? So that one will be, guys, do we differentiate a summation? It's with respect to z, right? So this becomes invalid when this is related to, even it's a x of n, so even that is invalid, right? So where it's small change over here, it's summation n equal to minus infinity to plus infinity, it's a x of n d by dz of z raised to minus n, because the differentiation will be applicable to this term over here, this term, it's with respect to z, isn't it? So in that case, the differentiation will be applicable to this term over here, this term with respect to z, isn't it? So differentiation will be done to this one, summation n equal to minus infinity to plus infinity, x of n d by dz of z raised to minus n. Guys, for a beginner, it's a small recollection for you. D by dx of x of n, what will be that? N into x into x raised to n minus 1, isn't it? The derivative of x raised to n. The same way, the same thing is applicable over here. So what is that? Summation n equal to minus infinity to plus infinity as it is, x of n also as it is, nothing is done with no operation on x of n. Here this comes as it is, as it comes down as it is, it's a minus n comes down, and z raised to minus n minus 1. Okay, so that's the transformation over here. And this could be summation, it's not could be, it is n equal to minus infinity to plus infinity, x of n and minus n. This could be split, powers are added, right? So this can be z raised to minus n, z raised to minus 1. Okay, so summation is for n equal to minus infinity to plus infinity, and this has got nothing to do inside the summation. No n over here that can be pulled out. In the sense z raised to minus 1 can be written. And a small transformation, watch carefully. We have a negative over here. Here it's a negative, even that negative can be written out over here. And now the summation as it is. Negative has come out, z raised to minus 1 has come out. It's a summation n equal to minus infinity to plus infinity. Okay, x of n, and hey guys, it's even n also inside. We have that n that didn't come out. It's a part of the summation into z raised to minus n. Okay, so what is this all about? It's a d by dz of x of z, right? So in that case, guys, hope it's transparent. Summation negative and z inverse came out, n is inside, x of n inside, z raised to minus n, and it's a z inverse, so that will be minus of z d by dz of x of z, which is equal to what? Guys, watch carefully. Now this is been shifted over here, this doesn't exist anymore this side. Now what is this? This entire term is multiplied with z raised to minus n, and summation is obtained from minus infinity to plus infinity. What is that? It's the z transform of n into x of n. Yeah, that's the final deduction. What it means, the z transform of n into x of n. That says, in order to evaluate the z transform of any function multiplied with n, just evaluate the z transform of that one and obtain the derivative of that one and simply multiply with minus z. Take it down. Let me tell you. So what will be the z transform? A small example. Okay, so what will be the z transform to make you more understand this one, to make you understand this one? What will be the z transform of here? What will be the z transform of n into a raised to n of u of n? What is this? Now match this one. From this one, what it says? In order to evaluate the z transform of any function multiplied with n, in order to evaluate the z transform of any function which is multiplied with n, obtain the z transform of this one. The first derivative of that z transform is multiplied with minus z, right? In the sense, now this one a raised to n u of n is multiplied with n, isn't it? So we need to have the z transform of this one. We have seen that one, z transform. Where is that? I erased it away. Z transform of if I'm not wrong, the z transform of a raised to n u of n should be z by y, should be, it is, isn't it, z by z minus a. Okay, so in that case, the first derivative of this function d by dz, guys, it's time to wake up your math skill in you. It's a u by v rule, making use of that u by v rule. Once again, the rough work over here, d by dx of u by v. How to evaluate that? It's a v square v du minus u dv, right? V square, that whatever is in the denominator as it is square, it's u, and the numerator will be having v as it is, and the first derivative of the numerator minus the numerator as it is and the first derivative of the denominator, right, according to u rule. In that case, here it's this is our v, so z minus a whole square, v by v whole square, right? And v as it is, in the sense z minus a, v as it is, z minus a into derivative of this one. So it's a d by dz, derivative of this is u, d by dz of z, that's 1 minus, right? It's a, what is that? U as it is, in the sense z as it is, and the derivative of the v, term v, derivative of this one, d by dz of z minus a. This is a constant, that becomes 0, and with respect to z, that becomes 1, and so we will be having 1 over here. Okay, so this is the case, and what we have, it's a Guys, denominator we have z minus a whole square. This is a z minus a into 1, that's okay, minus z. Okay, so in that case, watch carefully, z, positive z, negative z gets cancelled, and we have minus a by z minus a whole square. Okay, so that's the result. What is that? Derivative of this one. Now the z transform of this one, according to this rule, it's simply what it says, z raised to z transform of n into x of n, z transform of n into a of n, the first derivative of x of z, that's the first derivative of this one, is that multiplied with minus z. Okay, so that's multiplied, the first derivative minus of a by z minus a whole square is multiplied with minus z. So in this case it's a multiplication. Okay, the negative and negative is multiplied, that becomes positive, and finally what we have is a z az. Okay, so constant that comes ahead, a into z by z minus a whole square. Okay, so what it says, guys, not to confuse you, I'm writing over here very important terms. Where did we reach? Hope you understood the derivation, all the cancellation and all, final the deduction is this. The z transform of this one is this. So there will be a need, we will be in need of, in some deductions, not in some deduction, almost all the deductions will be in need of obtaining the inverse z transform of this one. So inverse, z inverse of a into z by z minus a whole square could be proceeded with n into this one. Could be like, if this is the case, we'll make sure that whatever equation is reduced to this one. Okay, rearranging all the terms and all, that could be brought to this point, and this inverse z of this one could be, y could be, it is n into a n u of n. Is a very deadly important z transform pair, inverse z transform, sorry. Okay, here when on, we started from here, right? So applying inverse z transform on both sides, this z inverse will be as it is, z inverse into z, that gets cancelled, and this is the reduction. Very important one. We can say that a 5-star rated relation, a 5-star rated reduction in z transforms. Yeah, believe me. Z transform of x of n. Guys, every story starts from here. I have to repeat it, right? Because repeating again and again, psychology says that repeated word gets registered into our permanent storage. So that's the reason. That's the reason I repeat that keywords in the class also. It's proved repeated words gets registered in our permanent storage memory. And here it's a x of n, the function x of n is multiplied with z raised to minus n, and summation is obtained. Guys, it's n. Okay, it's a n, and summation n equal to, guys, let me go for the bilateral. Unilateral something else. For the time being, it's a bilateral, minus infinity to n extending from minus infinity to plus infinity. That's the case. So if this is the case, what is the z transform of x of n minus 1? What will be that? The same thing, the given function, the given function x of n minus 1 is multiplied with z raised to minus n, and summation is obtained from n equal to minus infinity to plus infinity. Nothing to worry. The same thing, whatever the given function is multiplied with z raised to minus n. It's time to take out your math skill in you. A small substitution. In this case, if this is the case, we need to go for a small substitutions. Let me say that n minus 1, let me substitute it with p. Okay, so in this case, if this is the case, we need n also to substitute over here. We need to plug in only n over here. So going ahead from this very substitution, n will be equal to p. It's a negative 1, that becomes positive 1. Okay, so when we go for substitution, another important point to be remembered is we need to change the limits of summation. In that case, like from here itself, that isn't a rocket science again. We don't need to go somewhere else. When n starts from minus infinity, minus 1, what will be p? Infinite. We have infinite, that will be rounded to minus infinite. In the sense, when n starts from minus infinity, even p also starts from minus infinity. Okay, on the other hand, when n starts from this one, upper limit, when n starts from positive infinity minus 1, and p, does this stand in front of infinite? No, this becomes invalid. So it's completely positive infinite, which is equal to p. This says when n starts from minus infinite, from this very expression, p also starts from minus infinite. When n starts from positive infinite, I mean when n is positive infinite, even p is positive infinite. We have to make use of this when we go for substitution. Even in differentiation, even in integration, this is the rule we come across. Okay, so if that is the case, the summation it will be p. Okay, p will be minus infinite to plus infinite, and x, n minus 1 with p here, n minus 1 with p into z raised to negative as it is. Now n will be this one, it's a p plus 1. Okay, now I cannot see you, let me go ahead, I don't want to waste this time. Summation p equal to minus infinite to plus infinite, it's a x of p z raised to, guys, this could be split, the power could be split, minus p into z raised to minus 1. Okay, watch carefully, it has got no meaning being inside the summation. The summation is for p and we don't have this p, so that could be taken out from the summation. This is z raised to minus 1, and the summation p equal to minus infinite to plus infinite, it's x of p z raised to minus p. Okay, so in that expression, if we go for p equal to back to n, no change. If p starts from negative infinite, n also starts from negative infinite. If p is positive infinite, n also will be positive infinite. So that could be reduced to here, which is outside, it's a z raised to minus 1, it's a summation. Now going back for this one, p equal to n equal to p, n equal to summation, n equal to minus infinite to plus infinite, x of n z raised to minus n. Guys, watch carefully, what is this? It's a z raised to minus 1, which is out of the summation. It's x of z, a shifting property. Okay, it's a very once again it's a very important relationship, z transform of x of n minus 1. So what if we have minus 2? It's z raised to, it's a z inverse, a numerical, for better understanding, making use of all these important properties. Why did we derive? Where do we find the application? Many times there will be a need of evaluating the impulse response of a given system. Considering a system, for supposing a system described by the second order differential equation y of n, let's say y of n minus 4 times y of n minus 1 plus 4 times y of n minus 2, which is equal to x of n minus 1, supposing, if that is the equation, differential equation governing a second order system. It's this, so it's a second order system. If that is the case, obtaining the impulse response, making use of all these properties, okay, cannot be neglected. So if that is the case, obtaining the z transform of the whole equation, y of n, it's y of z, simply y of z minus 4 times, guys, this one, making use of this one, If it's the transform of x of n minus 1, it's a z inverse x of z. If it is a z transform of y of n minus 1, it's a what? In this case, it's a z raised to minus 1 y of z. That's it, plus 4 times. Now this one, the same way, it's a 4 as it is, z raised to minus 2 y of z, which is equal to, once again, yeah, this one, that very property. By default that has come out, thank God, I don't need to struggle much. So it's a z raised to minus 1 x of z. Okay, so taking out y of z as common from all the terms, what we have is y of z into this one will be 1 minus 4 times z raised to minus 1, guys, it's z, okay, plus 4 times z raised to minus 2. On the other side we have z raised to minus 1 x of z. Guys, it will be asked to evaluate the impulse response h of n. So prior to that we need to have the system function h of z, and the inverse transform of h of z will give us the impulse response which we are in search of, right? So in that case, y of the ratio y of z by x of z, which will be the system function h of z, will be pushing this to that side, it's multiplying going that side, that will be dividing z raised to minus 1 by 1 minus 4 times z raised to minus 1 plus 4 times z raised to minus 2. Guys, usually if we split this into beginner will be struggling to factorize if it's in negative. So taking out z raised to minus 2 from all the terms, what we have is, for the beginner, please watch carefully, now it's the game changer, z raised to minus 1 by, here taking out z raised to minus 1 as common from all the terms. If that is the case, z raised to minus 2, very sorry, yeah, z raised to minus 1, this has come out, z raised to minus 1 has come out, so that we will be left with 4, positive 4. Here z raised to minus 1 has come out, so one of the z is still inside, so minus 4 times z, and here z raised to minus 2 has come out, so we will be left with z square. Okay, so in that case, guys, one of the z raised to minus 1 over here and another z raised to minus 1 over here gets cancels, and here z raised to z inverse, what is that, 1 by z, so that will go up z. Okay guys, no confusion, z raised to minus 1, that will be 1 by z, isn't it? So this 1 by z flips up and that stays, that goes up, that sits on the numerator on our head, like, okay. And here a small simplification over here, watch carefully, it's a z square, okay, minus, can this be 4 written as 2 into 2 into z as it is? Okay, 4 I've written 2 into 2, that's 4, right, plus 2 square, 4 can be written as 2 square, isn't it? Now this is z square, okay, don't get confused with my z and 2, z I have a sleeping dash, don't mind. This, can you see, this could be reduced to something else, it's a square minus 2ab plus b square, sorry, a square minus 2ab plus b square. So how that can be reduced to, reduced to, very sorry, it's a z by, it's a, again, a square minus 2ab plus b square, a minus b whole square, right? So here a minus b, a is our z minus 2 whole square. Guys, match this equation to something else over that corner, but still we need something else. We have this a over here, we have this square, okay, match this one, completely match this one. We have z in the numerator, we have z in the numerator, and this is our z, okay, z, we have a being this one, we have a over here, and even we have square, but we don't have this a over here. What is a in this case? It's 2. So can we do that to be 2 into 1 by 2, in the sense cancelling, that goes back to the previous one, right? So now this could be 1 half as it is, okay, this half as it is. Now this is in the standard form, okay, yep, okay, still it's 2 times z by z minus 2 whole square, which is equal to h of z. We are evaluating for h of z. Okay, the system function z, half, it's outside, a z by z minus a whole square, a z by z minus a whole square, right? So h of z, and we are in search of the impulse response, which I mean the inverse z transform of h of z will give us h of n, which is the impulse response, right? So here h of inverse z transform of h of z, which gives us h of n. So where to evaluate from? So inverse z transform of what? 1 by 2 into, guys, let me write more clearly, it's a 2, okay, it's a 2 into z by z minus 2 whole square. Guys, forget about this half, it's a constant, it's a half, it's constant. Can you see, can we match that one? It's a into z, z minus a, here it's same, right? It's same, a over here, 2 over here, 2, and a square and a z, right? So the inverse will go back to this one. So how to write that? Inverse of this will be going back to this. What is our a over here? It's a 2. So the inverse of this one, guys, that half is still staying outside, nothing to do with that. It's a constant, no transformation for the constant. It's a, how to write down that one? N times, what's our a? It's a 2 raised to n of u of n. Guys, this is that, which is the h of n, which we are in search of, making use of the properties, right? So I could straight away at a snap, I could do this because we have already done this one. So in that way we can make use of the deductions, some standard deductions, some standard, it's a property, it comes under the shifting property. Shift in time domain results in the multiplication of inverse of this one z. So it says. So hope you understand this analysis. If you find it worthful, if you find it useful, support me with your valuable share and a subscription. Thank you for watching.